All right, big idea number 5, triangles. There are so many different things you need to remember about triangles. I'm going to try to break it down as simple as I can, but there's hopefully a lot of these things that you remember. To start, the difference between an equilateral, isosceles, scalene triangle mean. Equilateral is when all sides are the same. Isosceles is when just two of the sides are the same, and scalene is when no sides are the same. Equiangular means when all the angles are the same degree. Acute means all angles are less than 90. Obtuse means at least one of the angles is greater than 90. SOHCAHTOA is a little bit of trig. It's the sine, cosine, and tangent. Okay, sine is opposite over the hypotenuse. Remember, the hypotenuse is the leg across from the right angle. Cosine, or for the SOHCAHTOA, is adjacent, which is the right next to over hypotenuse, and tangent is opposite over adjacent. Okay, so if you remember that, a right triangle, I mean, you obviously know you have a 90-degree angle in there. Okay, you have a hypotenuse, which is across from the right angle. You have a side and a side. Okay. The area of a triangle is at 1/2 base times height. Similar triangles, X, Y, Z, A, B, and C. If I say these are similar, okay, and then that would mean that X over A, we kind of go into ratios. X over A would be the same thing as Y over B, which would be the same thing as Z over C. Okay, so all the ratios would be the same. It doesn't mean they're the same length or anything like that. Just the ratio between all the different sides would be the same if you have similar triangles. Triangle congruence, lots of proving. Remember all the proofs, how to prove things. Side, side, side. To prove that two triangles are the same, if you know that all three sides of each triangle are the same, then you know it's the same triangle. If you know all three angles, so angle, 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 are the same for each triangle, then they're congruent. Side, angle, side. If you have that, then you know that the triangles are congruent. Angle, angle, side. Again, another way to prove that triangles are congruent. And then last one is HL, hypotenuse, leg. If you know the hypotenuse and leg are the same for each triangle, then you have congruent triangles. Okay, so those are just some different ways to remember, or the different ways to prove triangles are congruent. This is probably the most difficult part, the corollary. The geometric mean, A over X is the same thing as X over B. Another way to put that would be short leg over short leg equals long leg over long leg. Or side 1 over A equals A over side 2, or H, which is hypotenuse over leg 1, equals leg 1 over side 1. Okay, so those are all the different things. This is, again, like I said, the most difficult, so I'm going to try a few of these with you. Another thing to remember before I go on, all angles in a triangle add up to 180 degrees. If you have a right angle, the other two angles have to add up to 90, those kind of things. So on number 1, they want to find X and Y. So if you look, you have multiple triangles throughout, some triangles within. So the 9 in one triangle might be the short leg, and then in another triangle, that same 9 would be the long leg, things of that sort. So if you look at this, if we want to just solve for Y to start. So Y is in this triangle right here. It's just a leg. Okay, so you'd have Y over 9. So that's a leg over a leg. Okay, and then if you look at this triangle, okay, you'd have Y and 3, so it'd equal long leg, so you'd have 3 over Y. So Y over 9 equals 3 over Y. And then you have to cross multiply to solve. So Y times Y is Y squared. 9 times 3 is 27. Take the square root. So Y would equal, again, factor tree, 9 and 3, 3 and 3, 3 square root of 3. Okay, so there's my Y. Okay, and then if you wanted to find your X, you could do that same thing and set that up. Or you could just use Pythagorean theorem. So what I'm going to do, make that a little bit smaller, sorry. And then I'm going to do 9 squared plus 3 square root of 3 squared equals X squared. Okay, so 81 plus, now 3 squared of 3 squared, remember that was from right here, square root of 27 squared, which is just 27, equals x squared. 81 plus 27 is 108, equals x squared. Take the square root of 108, and you get, let's see if that can go into, 9 can go in there 12 times. I'm going to do that over here. 9 can go in there 12 times. So you have 3 and 3. So you have a pair of 3s. 4 can go in there 3 times. So 2 and 2, pair of 2. So 2 times 3, you have 6 square root of 3. So if you simplified that radical, you'd get 6 square root of 3. Alright, so let's make that smaller. Okay, so number 2, same type of thing, if you can see it. This stuff was for number 1. So number 2, you have y over 21 would equal 4 over y. Cross multiply, y times y is y squared, equals 4 times 21, which is 84. Take the square root of that, so y would equal, that would be 4 and 21, 2 and 2, so you'd have y would equal 2 square root of 21 if you simplified that radical. Okay, and then if you plug that back in to try to find x, just using that triangle on the right side, you would have 4 squared plus square root of 84 squared, which is just 84, equals x squared. So 16 plus 84 equals x squared. So you'd have 100 equals x squared. Take the square root of both sides, you get x equals 10. Okay, so that corollary is probably the most difficult part, but make sure you remember everything about triangles. There's going to be a lot of different things that we're going to work on, so go ahead and try the independent practice.